Hello everyone, this is our session 15 on indefinite integration. We've done integration by parts in the previous session, the theorem on the same. Okay, so based on the theorem, there are some type of sums or you can say derivations that we should know. Okay, so we are going to do those now and then we can begin with the exercise. Okay, so let us start. First of all, let's first revise the theorem by parts. So what does it say? Integral u v dx, that is multiplication of two functions. Then how do you integrate? So it is u integral v dx, okay, minus integration of d by dx of u integral v dx, the whole thing integrated, okay, with respect to x. This is your integration by parts rule. Okay, now let us begin with some of the results that we need to know before we do the exercise. So what are these results? Like suppose if we come across types of integral of type root of a square minus x square, okay, root of x square plus a square, and root of x square minus a square. So if we are going to come across these as integrations, then how do you integrate it? So we have some results to prove with the help of integration by parts. Let us start. So first one says that integration of root of a square minus x square dx is equal to x upon 2 root of a square minus x square, okay, plus a square upon 2 sine inverse x upon a, okay, plus c, right? So how do you do integration of these kind of denominations or these kinds of functions? So there are no two functions here, but still we have to use integration by parts. So whenever you come across these kind of sums, your second function is considered as 1. Okay, now what is that? Let us see. So if I say that I is equal to integration of root of a square minus x square, okay, then my second function is missing, so I'm going to write it as in the form of a square minus x square into 1 dx. So which is my first function? This. And which is my second function? This. I'll write it with a different color so it will be easier to understand. This will be u and this will be v. Okay, let us use integration by parts to do this. So let's write the first formula using integration by parts. Every time you're using it, please mention the formula. Okay, integration by parts. What is the formula? The reason for mentioning the formula is a practice for yourself to know which term comes after which term. U integral v dx, okay, minus sign, integration of d by dx of u, okay, into integral v dx. Okay, let us begin for our sum. So I will be equal to integral u integral v dx. So what is u? Root of a square minus x square, okay, integration of 1 dx minus integration of d by dx of this function. So root of a square minus x square, okay, into integral v dx, that is 1 dx, okay. Yes, so now let us do the next step would be, what is integration of 1 dx? It will be x root of a square minus x square, okay, minus. Now the first integral remains as it is. Let's take the derivative of the term. So it will be 1 upon 2 root of a square minus x square into minus 2x, okay, into x dx, okay, which will be equal to, the first term remains as it is, no changes in this one, okay, minus 2 cancels out, you have integration of minus x square upon root of a square minus x square dx. Okay, now how will we do this? So in the numerator, we are going to get the terms of the denominator. Means what? The first one as it is, the term, there is no change in this one. Okay, minus integration of, now you have a square minus x square. So I'm going to get this term in the numerator. If I have put a term a square, then I will also subtract a term a square. Okay, divided by root of a square minus x square. And now we will separate this denominator to each of the terms in the, or rather we'll group the terms. So this will be 1 and this will be the second term. Okay, so we'll give it to each of the terms in the numerator. How do we do this? So x root of a square minus x square as it is, I over here, okay, minus, let's group the terms. So it will be minus integration of a square minus x square upon root of a square minus x square dx. Okay, minus into minus becomes plus, a square comes out, integration of 1 upon root of a square minus x square dx. Okay, so now this term over here, this second term here, okay, we'll rationalize it. So what do we get? I equal to x root of a square minus x square, okay, minus integration root of a square minus x square dx, okay, plus a square. Now what is integration of reciprocal? We've done this in the previous session. So integration of reciprocal will be equal to, or reciprocal of the term, which will be equal to sine inverse x upon a, okay, plus c. Or rather we'll take c1 because one integration is still remaining. Now what do you observe over here? This is the question itself. Let's go back to the question. What is I? Integral root of a square minus x square dx. Yes, so I've got I here already. X root of a square minus x square. And this term is also I. So we'll write it like this. Plus a square sine inverse x upon sine inverse x upon a plus c. Okay, now this I will go on to the left side. So I will have 2i is equal to, okay, 2i is equal to x root of a square minus x square, okay, plus a square sine inverse plus a square sine inverse x upon a plus c. Okay, now what is remaining? We'll take I here and we'll take 2 down. So x upon 2 root of a square minus x square plus a square upon 2 sine inverse x upon a plus c. Okay, this is what exactly we had to prove. So I is integration of root of a square minus x square dx, okay, is equal to x upon 2 root of a square minus x square plus a square upon 2 sine inverse x upon a plus c. Okay, so this is your proof. Let's check if that was the question also. So yes, the question was root of a square minus x square dx should be equal to x upon 2 root of a square minus x square plus a square upon 2 sine inverse x upon a plus c. That's exactly what we have proved here. Okay, so you can write hence proved in the end. Okay. Yeah, this was the result we wanted to prove. We are going to use this in the exercise directly. That's why I have proved it over here. If you want, you can solve it in the exercise as well, as in when we come across the sums, you can solve it there also. Okay. but depends on how many marks the sum is on. If it is for 2 marks, then you directly use the formula. You write the formula and you use it for the sum. Okay, let's go to the second derivation, second proof. Okay, so our next proof is second one. Okay, I is equal to integral of, or rather what we have to prove. So let me write that first. Prove that under root of x square plus a square integral x square plus a square dx is equal to x upon 2 root of x square plus a square, okay, plus a square upon 2 log of x plus root of x square plus a square, okay, plus c. Okay, this is what we have to prove. Similar method, we'll take the second function as 1, okay, and we'll use integration by parts. So let us begin. So let us say that I is equal to integration of root of x square plus a square, okay, dx. Second function is not there, so let us make the second function as 1. This is u into 1 dx. Okay, so we have this as u and this as v. We are going to use integration by parts. So I'll just write over here using integral u v dx is equal to u integral v dx, okay, minus integration of d by dx of u integral v dx, okay, dx. Yes, so let us use this for our integration. So I will be equal to, I is equal to u integral v dx. So first function as it is root of a square plus x square, okay, integral v, that is 1 dx, okay, minus integration of d by dx of root of x square plus, x square plus a square it is. It's the same thing actually since it's a plus sign, but we'll write it as x square plus a square root of x square plus a square integral 1 dx. Okay, the whole thing integrated with respect to x. Now integral 1 dx is x, so x root of x square plus a square, first term, okay, minus what is derivative of root of x square plus a square? The integration sign remains as it is, 1 upon 2 root of x square plus a square, okay, into 2x into x, the whole thing multiplied by dx, okay, which is equal to first term as it is x root of x square plus a square, okay, minus 2 cancels out. I have integral x square upon root of x square plus a square dx. So in the second term, again, as we did in the previous derivation, we were going to add, or we are going to get the numerator terms, denominator terms in the numerator. So we will have a square plus x square minus a square upon root of x square plus a square. And then we are group them. We have to group them and then we have to separate the denominator. Okay, so how will we group them? 1 second. Yeah, so this is the way you will group them. Let's start. So it will be equal to, or I will be equal to x root of x square plus a square, okay, minus integration of a square plus x square root of x square plus a square, okay, dx. Again, what do we have? Minus sign, so minus into minus becomes plus, a square stands outside, integration of 1 upon root of x square plus a square dx. Okay, this is one of the special integrals, this term over here, right? So we are going to use the formula for that. Here, if you can observe in the second term, you can rationalize the denominator. And so what do you get? X into x square plus a square minus minus integration of root of x square plus a square, okay, dx plus a square as it is integration of 1 upon root of x square plus a square dx. Okay, now what is the second term? It is the question itself. It is your integral I. Okay, so I is equal to, yes, so this,
You called him, no?
okay, so this will be a square. What is the integral of 1 upon root? It is log of x plus root of x square plus a square, okay, plus c. Right, now we'll shift the I on the left side. So we have 2i is equal to x root of x square plus a square, okay, plus a square log of x plus root of x square plus a square plus c. Okay, and then you can take the 2 down. So we have I equal to x upon 2 root of x square plus a square plus a square upon 2 log of x plus root of x square plus a square, okay, plus c. This is your integral value, okay. Now this is exactly what we had to prove. Yes, this is exactly what we had to prove. I equal to x upon 2 root of x square plus a square plus a square log of x square plus a square. Okay, so this is the second proof. There is a third proof also, root of x square minus a square. You can use the exact same method to do that proof as well. All these three proofs are important for the next exercise that we'll be doing. There are two more integral types that we need to know before we move on to the exercise. Okay. Okay, the next integral type is, it is actually not included in your portion as such. It's non-evaluative, but we should at least know the integral type. So I'm just writing it down. If you come across this type of a sum in your MCQs or in your entrance exams, then you would know how to solve it. So integral of type integration px plus q, okay, under root of ax square plus bx plus c, okay, dx. Now if you have integration of this type, that is a binomial multiplied by a root of a quadratic, then how do you solve it? So you write this term px plus q, okay, you will substitute it as a into d by dx of ax square plus bx plus c, okay, plus b, where b is a constant and a is also a constant. You use this derivative and then solve the integration. Okay, so when you come across this integral type, you can solve it in this method. Also remember, I'm repeating it, this is a non-evaluative part of your board exams. Okay, it's not included in the 12th standard syllabus for this year, but you should know how to solve it for your entrance exams. Okay, this is one type. Now the last type under integration by parts is integral of type integration of e raised to x f of x plus f dash of x, okay, dx is equal to e raised to x f of x plus c. Okay, now let us try and solve this by either by integration by parts. So we'll just check the proof of this integration. Why do we get the answer as e raised to x f of x plus c? Okay, by definition of integration of parts or integration by parts, Okay, so do you remember what is integration by parts? Integration of uv dx is equal to, what do we write as? Integration uv dx is equal to u integral v dx, right? Minus integration of d by dx of u integral v dx, the whole thing into dx. Okay, so we are going to use this for which function? For the function integral e raised to x f dash of x dx. Okay, let us use it for this function. So this is u. Let's put it in a different color. So this is u and this is v. Okay, let us use integration by parts for this function. So u v dx, so e raised to x integral f dash x dx, okay, minus integration d by dx of e raised to x integral f dash x dx. Okay, let us solve this part. So we'll get integral e raised to x f dash x dx is equal to, what is this? E raised to x, integration of f dash x dx is f of x, because the f dash x is what? Derivative of f of x, right? So integration of f dash of x will be the function itself. So f of x e raised to x, okay, minus integral sign as it is, d by dx of e raised to x is e raised to x, integral f dash x dx is f of x dx. Okay, what we can do is we can shift this integral part over here, and here we'll have plus c or constant. So integral e raised to x f of x dx plus integral e raised to x f of x dx is equal to f of x e raised to x plus c. Okay, so this can be written as e raised to x common f dash of x plus f of x, okay, integration dx is equal to e raised to x f of x plus c. Okay, so this is a formula that we have derived. You can use a different method of derivation as well. Okay, that is by taking derivative of e raised to x f of x also, you get the same answer. Okay, so you can try it by that method also. Now, this we are going to use in the next exercise as a formula directly. So if we come across this type of the pattern where you have an exponential function and then you have derivative plus the function, okay, then you can use the formula e raised to x f of x plus c. Clear? So this is fine. Now, let us move to the exercise based on these integration by parts. Okay, so it's exercise 3.3. Okay, it is divided into three subtypes. I'm starting with the first subtype. Okay, so the first subtype says that evaluate the following. So there are sums using integration by parts. So every time I'm going to use the uh, formula, I will write the formula for you so it becomes easier to remember. First one, integration of x square log of x dx. Okay, so in this, how do we decide what is u and what is v? Okay, so if you remember the lie 8 rule, I'll put it down here for you. So it is L, I, A, T and E. Okay, so what is x square? It is an algebraic function. And what is log x? Logarithmic function. So what you can see the order over here, first you have logarithmic function, then you have algebraic function. So what we are going to do is rearrange the integration over here. So we'll say therefore I is equal to integration log of x into x square dx. Okay, and then we call the first function as u and the second function as v, and then solve by integration of parts. So by integration by parts, what do we know formula as? Integral uv dx is equal to u integral v dx, okay, minus integration of d by dx of u integration v dx, the whole thing multiplied by dx. Okay, so we're going to use this for our function over here, I. So I is equal to, okay, which is our function u v dx. So u integral v dx log of x integral x square dx, okay, minus integration of dy dx of log of x, okay, multiplied by integration of x square dx, okay, dx. Okay, so what will be the answer? I will be equal to log of x into x cube upon 3, okay, minus integration of d by dx of log of x is 1 by x, okay, into x square dx integration is into x cube upon 3 dx. Okay, this will get cancelled. So we have x cube upon 3 log of x minus 1 upon 3 integral x square dx, okay, which will be equal to x cube upon 3 log of x minus x cube upon 9 plus c. What we can do is take x cube upon 3 common, and we have log of x minus 1 upon 3 plus c. Okay. Also, this can be written as x cube upon 9, okay, bracket 3 log of x, that is taking LCM, okay, minus 1 plus c. Okay, so that could be your final answer. This is the first sum, exercise 3.3, question 1. Okay, moving on to the second one now. It says integral x square sine 3x dx, integral x square sine 3x dx. Okay, again, let us remember the Layet rule. Let's write it. What is the Layet rule? L-I-A-T-E. Okay, rather what we'll do is we put it in horizontal format here, so it's occupy less space also, and you'll know what is to be used also. So it'll be L-I-A-T-E. Okay, which two type of functions we have? One, we have algebraic, then we have trigonometric. So are they in the same order? Yes, algebraic first and trigonometric second. So they're in the correct order. We can directly use the formula. So I is equal to integration of x square sine 3x dx. Okay, this is u and this is v. Okay, what is our formula? uv dx is equal to u integral v dx, okay, minus integration of d by dx of u integral v dx, right, plus dx. So what is the answer for I then? I is equal to u integral v dx. So x square integration of sine 3x dx minus integration of d by dx of x square integral sine 3x dx, okay, the whole thing dx. So what is the integration of sine? It is minus cos 3x, so minus x square cos 3x upon 3, okay, minus integration derivative of x square is 2x into sine 3x derivative minus cos 3x, okay, divided by 3 dx. So I is equal to minus x square cos 3x upon 3, okay, minus sine 2 upon 3 common, integral of x cos 3x dx. Again, what you will do? Again, we will use integration by parts for this part of the sum. okay, x cos 3x. So how do we use that? The first term remains as it is, minus x square cos of 3x upon 3. Use the same formula again, so minus 2 upon 3 integration. X cos 3x can be, or sorry, let's use integration by parts over here. So this is u and this is v. So x integral cos 3x okay, dx minus integration of d by dx of u, that is x integral cos 3x dx. Okay, and derivative dx is missing, so sorry, not derivative, this dx is missing. Okay, close the square bracket. Okay, now what we'll do is finish the second integration. So x square cos 3x upon 3 minus 2 upon 3 as it is. X cos 3x integration is sin 3x upon 3. Okay, minus derivative of x is 1. Okay, integration of cos 3x is sin 3x upon 3 dx. Okay, let us continue with this. So I am going to get minus x square cos 3x upon 3 okay. Now we'll put the 2 upon 3 inside, so I'm going to get minus 2 upon 9 sin 3x. Okay, also minus 2 upon 3 multiplied by minus is plus 2 upon 9. Okay, multiplied by, what is integration of sin 3x? It will be minus cos 3x upon 3 plus c. Okay, so we are going to get minus x square cos 3x upon 3 minus 2 upon 9 sin 3x minus 2 upon 27 cos 3x plus c. We can take 1 upon 3 common amongst all of them. Okay, so the final answer either could be left at this, or you could take okay, there was a sign mistake here. Minus x square cos 3x upon 3 minus integral 2x minus cos 3x. This minus sign goes out and becomes plus. So we have plus over here. Okay, and then plus 2 by 3 cos x cos 3x minus integral dx d by dx of x integral cos 3x dx. Okay, then you open up, so you get plus sign here and you get minus sign here. Okay, so sorry for this. Yes, so that is your final answer. Okay, minus x square cos 3x upon 3 plus 2 by 9 sin 3x minus 2 by 27 cos 3x plus c. Okay, so that here we complete two sums from exercise 3.3. In the next session, we'll do the remaining sums. If you have any doubts regarding when you're solving this exercise, do let me know. Okay, thank you so much.